This is 4.8, example 3 from your notes, and it has graphing f of g of x, where you have one function inside another. So I've often used the analogy throughout the years that these composite or composition functions are kind of like M&Ms, where you have chocolate inside a candy shell, right? You have one treat, chocolate, inside another treat, candy shell, right? And even better M&Ms are peanut M&Ms, where you have the peanut inside the chocolate, inside the shell, okay? Some like the pretzel M&M, some like almond. There are several kinds now. But that's what these composite functions are. You have one function, which would be the x squared minus 4, inside an outer shell. And the outer shell here is the absolute value. So the outside function is your f of x, absolute value, while the inside function is your g of x, which is the red one on the inside. So that's how we answer the first two questions here. What is f of x and what is g of x? You see that you have the red function inside the blue. So that's the M&M analogy. You would see the peanut M&M if you had something like f of g of h of x. That would be like a peanut M&M, where inside in the very center would be this h of x. That would be the inside function. Then the chocolate layer would be your g of x. Then the outer shell would be your f of x. So you work your way out from the inside. All right? We haven't seen many of those triple functions yet, but we may. So let's go back to this page, and they want us to try to graph this thing. So what you want to do is think about a table of values. That's typically what we do when we're first exploring a graph. It's sort of like dipping your foot in the pool and seeing what the temperature's like. All right? That's what a table of values can do for you. So what you might want to do is just sketch a quick little table of values. And think about what the inner function is. It's x squared minus 4, right? X squared minus 4. What would that look like if you were just graphing that? X squared minus 4. It would be a parabola a little down. How far is a little down? 4 units down, right? It would be a parabola shifted 4 units down. So maybe I'll skip the table of values for now. So if you were graphing x squared minus 4, it would look like this. A parabola shifted down 4. You'd go down 2, 3, 4, and put a dot. This is just the graph of the inside function. And then you would just graph what a parabola looks like from there. From your vertex, a parabola goes over 1, up 1. I know this because I understand the parent function x squared. I know what it looks like. It's over 1, up 1, back to the vertex. Over 2, up 4, because 2 squared is 4. Go back to the vertex. Over 3, up 9, because 3 squared is 9. Then on the other side of the y-axis, you have symmetry. So does everybody agree that this is a decent drawing of x squared minus 4? The students say yes. All right. Now, what would happen to it if you did this to it? If you put that function in those bars, if you put it in jail like that, what is the jail, the absolute value bars, telling the inside to become? As when it comes out, it should become the absolute value, which makes it positive, okay? Not necessarily opposite, because the absolute value of a positive is a positive. It stays positive. The absolute value of a negative must be positive. So the absolute value turns things positive. Okay? So here's what the bar does. What does it do to the part of the graph up here that's in the positive region? Nothing. Absolute value bars don't make things negative if they're positive already. It leaves them alone. Okay? It would be like, never mind. I was going to give an analogy. Not necessary. All right. So these outputs up here are also positive, right? They stay positive, right? The absolute value bars do nothing to them. You're going to flip them and make them positive, right? All of these values that are down here are going to get flipped up. No. It's going to open down. Did you say it's going to open down? Yes. That part will open down instead of up. It's going to look like a W. It's going to look like Weezer, if you've ever seen, like a little bit like the W, or Wu-Tang. Yeah. Okay? That's what it's going to look like. This point, for example, was at 0, -4. The absolute value forces it to 0, +4. This point over here was at 1, -3. The absolute value is going to flip it up to 1, +3. This point down here was at -1, -3. The absolute value forces it up there. So what happens is the graph stays normal, reflects, and then is normal again. That's the graph of the absolute value of x squared minus 4. To try it on your calculator, enter y equals enter y equals, clear anything old out. To put in the absolute value, you go to Math, and then over to the Number menu, and select number 1, ABS. My calculator has an old operating system, so it leaves the ABS. Some of the newer ones actually put the bars in. Most of yours probably do. Anyway, now we put the inside, x squared minus 4. And when you graph it, you should see that W again. So zoom 6, standard window, there it is. It forces anything that was in the negative y region positive. That's what the ABS is, the absolute value.